So welcome to Oracle Goldengate regular classes. My name is Ashish Agarwal and I'll be delivering this training to you. So the agenda of this training is, first of all, we're going to start with introduction to Oracle Goldengate, then architecture of Oracle Goldengate. The architecture of Oracle Goldengate is pretty much important, just like architecture of a Oracle database. So we are going to discuss on that. The most important part of this training would be architecture. Then we'll do the installation of Oracle Goldengate. So the installation is very simple. It's not very complex, just like the database, and the size of the binaries is only 30 MB. Then we'll discuss about various concepts and components which are involved in Oracle Goldengate. Then DML replication, Rashmi, as you said, the DML replication implementation part would come over here. DML replication initial load, we are going to do various demos of these. Then data filtration and transformation. The important aspect of this training means the important aspect of Goldengate. Why does Goldengate scores over data guard? So data filtration and transformation. Bidirectional configuration. Again, it is active and it is possible to replicate data between source and target on both the environments. So bidirectional configuration we are going to discuss. Then next we are going to discuss DDL replication. Goldengate can also replicate your DDL as well. So we are going to discuss DDL replication as well. Then monitoring the lag. The performance aspect we'll discuss over here. How to monitor the lag, what we can do to reduce this. We are going to discuss. Then we are going to do some troubleshooting related to Goldengate. And checkpoint. This checkpoint actually some terms, when you come across, some of the terms are similar with respect to database and Goldengate. However, this checkpoint is completely different from database. This is Goldengate checkpoint. So this checkpoint is used for maintaining data integrity. How this is used and what is the internal process, we are going to discuss about that. The next would be DefGen. DefGen stands for definition generation. So it is being used when your source and target table structures do not match. In that scenario, we use DefGen. So we'll see the usage of DefGen and how to configure the DefGen, how to use the DefGen. DefGen is basically a utility. So how to use this DefGen utility. Next, we are going to discuss about configuring Goldengate security. So in today's IT world or anywhere, data security is very important thing. This data should not be exposed to the outer world. So how does Goldengate manages that? We are going to see how Goldengate do that. Then another important aspect, parameters. We are going to discuss various parameters related to Goldengate which you can use in your environment. There are n number of parameters, we are going to discuss some of them. Another best part of parameters in Goldengate is they are simply plain English, means whatever parameters you use, they are simple plain English. So you can understand the usage quite easily. We'll see how. And last would be log dump. So log dump is used just like a archive files which are binary format archive log files which are not readable. Similarly, log dump is the utility which is used to read your local trail file and remote trail file which stores the data. So we'll see what are trail files and how to use log dump in the last. So Oracle database architecture. So Oracle database architecture is divided into two parts, Oracle instance and Oracle database. Oracle instance consists of various memory parameters, library cache, Shared pool is divided into two parts, library cache and data dictionary cache. Then next is database buffer cache, redo log buffer, Java pool and large pool. So Goldengate, first of all, how did Goldengate got its name? So Goldengate was developed by Ted Thompson and it was named after famous Golden Gate Bridge in San Francisco. Okay, now Goldengate is a change data capture tool. Now what do we mean by change data capture tool? It captures the changes which are happening in the database. It captures the changes occurring to the data in the database. So only changes are captured from the source database and those changes are sent over TCP IP network and applied to target database. So in Oracle database, where I'm not going to discuss this whole Oracle database architecture because it is quite big. So we are going to discuss related to Goldengate. So where the changes are being stored in the database. First, the changes from redo log buffer, the changes are stored into a redo log file. Redo log buffer, whatever changes you make in the data, first the changes goes to redo log buffer and LGWR log writer process works in the background and it writes those changes to your redo log file, which are part of a Oracle database. Oracle database has three kind of files: data files, control files and redo log files. So the changes which you are making to the database, those changes will come to redo log file from redo log buffer. So redo log files are the files which stores the changes, whatever changes you are making to the database. Now from redo log files, archive log file gets generated. Archive log file is the backup of your redo log file. So whatever changes you are making to the database, those changes are stored into your redo logs and in turn the backup of redo log file is generated as archive log files. So any change data capture tool, not only Goldengate, any change data capture tool, be it your data guard or any other IBM tool or any other tool, the changes, whatever changes it has to take, the changes will be taken from redo log file and archive log files in case of your Oracle database. In case of other databases, it would be a transaction log. The transaction logs in case of Oracle database are referred to as your redo log files and archive log files. So whatever changes are happening in the database, those changes get stored into your redo log files or archive log files. Okay, so there are various competitors in market for Goldengate currently. So there are various competitors from Oracle Goldengate. There are various competitors for Oracle Goldengate. So IBM has its own tool in the market, which is IBM Mirror. Hitachi has its own tool, which is known as Hitachi True Copy. Then HP has its own product, which is known as Continuous Access. Symantec has its own product. EMC Recover Point is also there. However, Goldengate is the most popular tool. We'll see why and how. We'll discuss it as the session goes on. There are various solutions available, but still Goldengate is very much widely used currently. So why Goldengate? Data is sent in real time with sub-second latency. Now, any change data capture tool performance is measured in two aspects. Any change data capture tool performance is measured in two aspects. One is your data integrity, and next is your lag. Jagata, I brushed through that Oracle database architecture considering you are Oracle database administrator, right? So that's why I didn't.
No, I am not an administrator. I am just a developer.
So you
Yeah,
understood
you can go ahead.
you understood that architecture part, correct?
Yeah, right.
Okay.
Yeah.
Yeah. So any change data capture tool performance is measured in two aspects. One is data integrity and another one is lag. Now performance, first of all, any tool which is replicating data from source to target, first thing which it has to ensure is data integrity should be maintained. There should be no compromise with the data. There should be zero compromise with the data, right? So Goldengate or any change data capture tool has to ensure that data integrity is always maintained. Means whatever it has to replicate from source to target, that should get replicated without compromising the data. Means whatever I have to replicate, suppose there are 10 rows at source and I have to replicate 10 rows. Those 10 rows on target, those should get replicated without any issue. So data integrity should be maintained. Now next comes lag. Now what do we mean by lag? The time difference at which a record gets committed at source and the time at which it gets applied on target. That time difference is known as lag. So suppose I'm getting, I have committed the transaction at source at 30 past 7 and it takes and it gets applied on target database at 33 past 7. So the time difference between the data getting committed and data getting applied is 3 minutes. So that time difference of 3 minutes is known as the lag. Okay, so this time difference is known as lag. So minimum the lag is, good the performance is. So the first aspect is there should be zero compromise with the data integrity along with the time difference between which a record gets committed at source and it gets applied at target should be minimum. So minimum the lag is, good maximum the performance of tool is. So Goldengate scores over other tool in aspect of maintaining the data integrity with minimum lag. Now next is it supports heterogeneous environments across different databases and hardware types. Now it also works, Goldengate, you can use your Goldengate from Oracle to non-Oracle, non-Oracle to non-Oracle, Oracle to Oracle and non-Oracle to non-Oracle. So Goldengate works on a heterogeneous databases as well. It's not as if it works between Oracle to Oracle only. It works from non-Oracle to non-Oracle. Your source could be MySQL, your target could be DB2. It will replicate the data. Your source could be Oracle, the target could be, say, Exadata. It will work on that. Again, it works on various platforms as well, just not like your data guard that it has to be, means on data guard the source and target should be on same platform. So if your source is at Windows, your target should be at Windows. It is not the case with Goldengate. Your source could be at Windows, your target could be Linux. Now other important aspect of Goldengate is high performance with low impact. Now any change data capture tool, if you're putting it in your database, it has some, I won't say it has zero impact, but any change data capture tool has some impact on the database. However, the impact of installing Goldengate on database is very low. It's not that high. So the impact is very low, and the performance it generates is very high. So the high performance with low impact. Ability to move large volumes of data very efficiently. So the data which gets moved from source to target, Goldengate can move your large volume of data very efficiently and very easily. So it moves data from source to target very easily and very efficiently. No single point of failure. We'll discuss this point later on once we are through with your architecture, Goldengate architecture. So there is no single point of failure. We'll discuss this point, okay? Now there are various places why Goldengate it is best in class leader in real-time data solution. So it complements existing Oracle products. The another part is Goldengate is a ETL tool, means extract, transform and load. So it also works with existing Oracle products. Now continuous availability for heterogeneous system. So it provides you continuous availability, real-time data access for reporting. So means in Goldengate you could ensure that both the sites, your source and target, are in open mode. So what you can do, you can suppose take the example of financial, say any bank. Okay, so in a bank most of the load on database is there because of reporting. So what you can do, means transactions occur on the same server and reporting jobs which are run every day, those also occur on the same source box. So what you can do, you can using Goldengate, what you can do, you can replicate the data to the secondary server, and your one server would be used for transactions, and all your reporting jobs could run from the secondary server on which data is getting replicated. Now real-time data for BI, business intelligence, EPM and Exadata. So it also works and complements your business intelligence tools. And in today's world, Goldengate along with ODI solution is best in the market. It also provides the option of zero downtime migration upgrades to Oracle database and applications. So if your database is 10G and if you want to migrate or upgrade it to 11G, Goldengate provides you the option of migrating it with almost zero downtime. It is not zero downtime, but it is almost zero downtime. You can say minimum downtime. So this is very good feature. We'll see. We'll discuss this point later on as well. Now over 400 customers, these statistics are taken from Oracle site, and these statistics are quite old, maybe 2010. So right now it may have increased. So top 3 of 5 largest commercial banks are using Goldengate. Top 3 busiest ATM networks are using Goldengate. Top 7 of 10 financial data services companies are using Goldengate. Top 4 of 5 telecommunications providers are using Goldengate. And top 3 of 5 largest food and drug stores are using Goldengate. So Goldengate scores over other competitors in the market because of the reason it provides you lot of solutions It works with various Oracle products right now. It provides the option of migrating the database in almost zero downtime, and it also works with your various business intelligence tools, and it moreover it works on heterogeneous environments as well. So it provides you high availability, zero downtime upgrades and migrations, live reporting, and business intelligence. These are the Oracle Goldengate solutions. Now, so far, if you'll see, we have been discussing that it provides you the option of heterogeneous, it supports heterogeneous environment. So by heterogeneous environment, we mean that it works on your heterogeneous databases and heterogeneous platforms. So heterogeneous databases means it not only works on your Oracle database, it works on your non-Oracle databases as well. So your source could be Oracle, your target could be non-Oracle. Goldengate will replicate the data. Your source could be non-Oracle, your target could be Oracle. Goldengate will replicate the data. Your source could be non-Oracle, your target could be non-Oracle. Goldengate will replicate the data. And your source could be Oracle, target could be Oracle. Goldengate will replicate the data. Now, if we compare it with the data guard, if we compare it with the data guard, the concerns are your source should be Oracle, your target should be Oracle only, and your source and target should be on same version. So if your source is an 11.203, the target should also be on 11.203. Otherwise, your Goldengate, your data guard won't be able to replicate the data. However, these consideration or these restrictions are not there with Goldengate. Again, another thing, Goldengate works on your heterogeneous platform. So your source database could be on Windows, your target could be on non-Windows. Your source could be on Linux, your target could be on Unix. Goldengate will replicate the data. However, with data guard, again the issue is your source should be on same platform. So if your source and target should be on same platform. So if your source is on Windows, your target should be on Windows as well. Again, another thing, with Goldengate, your source and target both could be active mode. With 11G R2 onwards, your data guard, there is an option of active data guard as well. Right. So these are the various options which Goldengate supports. So you can capture the data from Oracle, IBM DB2, Microsoft SQL Server, Sybase, Ingress, Teradata, Nscribe, SQLMP, SQLMPack, and you could deliver this data to all the listed above or MySQL, HP NewView. It also supports Netezza. And another thing, Goldengate first when it was developed for your Nscribe solutions for ATM network. Goldengate was a company which was developed in 1995 by two individuals. Okay, and it was specially developed for that Inscribe database which is used in your ATM network. In 2009, Oracle acquired it and renamed it as Oracle Goldengate in 2009. Now various operating systems and platforms which are being supported by Goldengate are Windows 2000, 2003 and X. All version of Windows it supports. Linux it supports, Sun Solaris, then all HP variants it supports, and all IBM variants it supports. So we are now going to discuss about architectural overview of Goldengate. So next we are going to move ahead with the architectural overview of Goldengate. So one thing, the Goldengate architecture is similarly very much important to your Oracle database. So just like your concepts are developed for database, if your architecture is clear, similarly for Goldengate as well, for developing the concept, your architecture should be pretty much clear. So this is very much important thing which we are going to
Ashish,
discuss.
Ashish, sorry to interrupt. There is one question. I think I lost audio that time. I think.
So architectural overview. So you have source database and target database. So your source database could be Oracle or non-Oracle. Your target could be Oracle or non-Oracle. Now as we discussed earlier, Oracle Goldengate, it's a change data capture tool. So change data capture tool, it reads the transaction from your redo logs or archive logs in case of your Oracle database, and in case of non-Oracle it is going to read data from your transaction logs. So there is a capture process in place. Capture process is a Goldengate process. So capture process, it reads your transaction logs or archive logs and redo logs in case of Oracle database and captures the committed transactions only. Capture process reads your transaction logs and captures committed transactions only. Okay. Then once the transactions are captured by a capture process, it writes them to your trail files. Now trail files, as they exist on source system, those are known as a source trail file, or you could also call them as local trail file because they are local to your source. Capture process captures the committed, it reads your transaction logs, captures the committed transactions, and whatever transactions are committed, it writes them to your source trail file. Source trail files are your binary format trail files. Those are just like your archive log files, you can say. Okay, so once the data is written into trail files by the capture process, there is another Goldengate process which comes into picture, data pump. Now data pump reads the data out of your local trail. Data pump reads the data out of your local trail and sends the data which it has read from local trail over TCP IP network to trail files on target. Now trail files on target are known as your remote trail because they are remote to your source. So data pump reads the data out of your local trail, sends them over TCP IP network to remote trail. And then there is another Goldengate process which comes into picture, which is known as delivery process. Now work of delivery process is to read the data out of your remote trails. Work of your delivery process is to read the data out of your remote trail and apply them to the target database. So the actual changes are being made into the database by your delivery process. Okay, so I'll again repeat this architecture. There is source database at which transactions are occurring. There is target database at which whatever transactions are occurring at source database have to be replicated. So the source database and target database both could be Oracle or non-Oracle database. Now there would be capture process which we would be configuring, which reads the data from your transaction logs. In case of Oracle database, these transaction logs are known as your redo logs or archive logs. So capture process reads your transaction logs and captures your committed transactions. Your transaction logs will contain committed as well as non-committed transactions, right? So capture process is going to read your transaction logs sequentially and will capture only and only committed transaction. It will ignore your non-committed transactions. Now once the committed transactions are captured, it will write those committed transactions to your local trail file. Local trail file which are local to your source. Now once the data, suppose, say for example, I have one table. I have inserted 1 comma ABC. So what would happen? Capture process will capture 1 comma ABC and write it to local trail. Once the data is returned to the local trail 1 comma ABC, data pump is going to read the data out of your local trail 1 comma ABC and sends it over TCP/IP network to remote trail. So 1 comma ABC was captured by capture process, returned to your local trail. Pump will read 1 comma ABC, sends it over TCP/IP network to the remote trail. Now remote trail consists of data 1 comma ABC. Then delivery process will read the data out of your remote trail 1 comma ABC and apply it to target database. So 1 comma ABC was committed at source and it got applied on target database with the help of 3 Goldengate processes: capture process, data pump process and delivery process. Now this is the unidirectional case. Now bidirectional is nothing, you can just consider it as a two-way unidirectional. So now whatever activities occurred in unidirectional, in bidirectional same kind of activities are going to occur. So now there would be another capture process. Now earlier target will now act as source and earlier source will now act as target in case of bidirectional. So in case of bidirectional, what would happen? The capture process now would exist on new source. There would be a set of source trail existing on new source, and data pump will capture the data pump will read your local trail, sends it over TCP/IP network and sends it to new target. Now target trail will contain the data, replicate process will read the data out of your new target trail and apply them to new target. So consider bidirectional as two-way unidirectional, that's it, nothing else. Bidirectional is simple, it is nothing but two-way unidirectional. So in case of bidirectional, your capture process, data pump process and delivery process, all three of them would exist on both the environments along with your local trail and remote trail.